Hi, everyone. We have a question in calculus here. We have a question about a piecewise function. So we can take a look at what's going on with the square root of 16 minus x squared. That would be only in the domain of 0 to 4, not including the 4. We can start graphing to make sure we get a visual of this. Beyond the 4, at 4 to 6, that function will behave as just a constant, as a 2 pi. So I've written this up. I've sketched out a few points, and the solution is here, and it comes through pretty quickly without actually having to do an integration. We know that integration is referring to area under a curve down to the x-axis. So all we really need here is to understand what is happening, and sketching things helps quite a bit. So that's our x-axis. This is our function. And the piecewise function in two parts, what we really have is what comes down to, it's a circle. If you look at that, let's see if this pen will stop jumping. There we go. And the way you can say is f of x equals 16 minus x squared and the square root. All right, so that is picking up on the first portion of the function, which if you square both sides of the function and rearrange, you can see that's the formula for a circle. So I've sort of started to sketch out that portion of a circle that would exist in here by plotting a few points. Again, it's one way to solve problems, is to be able to see graphically what's going on. But the area under a circle is already known. The area of a full circle is pi r squared. So we're going to be talking about a radius 4 circle. And the idea that 1/4 of that is what we're interested in. So only that portion of a circle. So we're going to divide by 4. So that effectively gives us our integration from 0 to 4. That's part of the job. But we're going to also need the portion from 4 to 6. So that's this portion, which is really just a rectangle, and it's 2 units wide by 2 pi. That was the value for that function, constant value. So we know the area here is 4 pi. We solve the area over here to be 4 pi also. That's 1/4 of the circle area. Add them up and you get the 8 pi. So it's something you can also prove out by doing integration. If you go forward and integrate this portion of the function and range it over the limits of 0 to 4 for a definite integral, you will be able to get the same exact answer, but that is not as straightforward, trivial, simple as recognizing that we're dealing with a circle and that we already know the area.